So in these examples, I want to find the angle between two vectors. I'm going to do two versions of this problem. The first a 2D, and then the second I'll do a 3D example. In both instances, I'm using a formula. The formula is not something that you need to memorize. It will be given to you. If we had a little more time, in a different sort of class, we might have talked about where this formula comes from. It is the law of cosines in vector form, but that's sort of beyond the scope of what students are responsible for. I need you to be able to know how to use this formula to find the angle between two vectors. That top part is the dot product. And then the bottom are magnitudes of the vectors. So in order to find this angle between my vector A, 10, 8, and my vector B, negative 3, 4, I'm simply going to say cosine theta equals, now the dot product is where I multiply the x components together, 10 times negative 3, and the y components together and multiply, so plus 8 times 4, and then divided by the magnitudes. And so the magnitude of A is going to be 10 squared plus 8 squared, and then times the magnitude of B be negative 3 quantity squared plus 4 squared. So in the top I'm getting negative 30 plus 32, and in the bottom I'm getting the square root of 164 times 9 plus 16, the square root of 25. So negative 30 plus 32 is 2 over the square root, using my calculator, 164 times 25 is 64.03. So the cosine of theta equals, pretty small number, 0.03. And so to find theta, I'm going to say what is the inverse cosine of 0.03. And my calculator will tell me in degree mode, 88.2 degrees. And so that's the answer to this question. What I like about this, what is cool, what should make you feel powerful, is if I say find the angle between, say, vector C, which is negative 3, 1, 2, and vector D, which maybe is 7, 4, negative 1. It's that same formula. I'm still going to say cosine theta equals, dot product of C and D divided by the magnitudes, the product of the magnitudes. So here, cosine theta equals the dot product, so negative 3 times 7, x coordinate times x coordinate, plus 1 times 4, y coordinate times y coordinate, plus 2 times negative 1, z coordinate times z coordinate. And then the magnitude of a three-dimensional vector is going to be negative 3 squared plus 1 squared plus 2 squared, and then times 7 squared plus 4 squared plus quantity negative 1 squared. Negative 21 plus 4 minus 2 over the square root of 9 plus 1 is 10 plus 2 is squared is 14. 49, 50, 66. And so putting this all together, I end up with the cosine of theta equals negative 19 over the square root of 14 times 66, which is about 30.4. So the cosine of theta equals negative 19 divided by that, 0.63. And so theta equals the arc cosine of negative 0.63, 128.7 degrees. And so even though we're in 3 dimensions, that same formula works and I can find that angle between the vectors.